All right, now reaction number 2 of alkanes is going to be what sometimes you see them call it the halogenation. Okay, halogenation, which means we are adding a halogen. A halogen is somebody from group 7, which is either chlorine or bromine or iodine or astatine. But the ones we will really be looking at is chlorine and bromine. Those are the ones really. Halogenation of alkane. Okay. Now, halogenation of alkane. We are adding a group 7 to an alkane. Okay. Here's what happens. Here's the general reaction. You have this guy. Let's start with your alkane. We'll just say RH. Okay. And he is going to react with a hydrogen, XX. XX for halogen. Here, you need sunlight. So we say light, or we can have heat, but this you need sunlight. Okay, which sometimes you see us call it UV or HV here, light. Okay, that's sunlight, light from the sun. What you're going to have is substitution. Hydrogen is going to swap with this X. So what we are going to have is, as our product, we have RX plus HX. That's what we are going to have now. They are going to swap. This is what happens in this reaction. Okay, that's what generally happens. That's just the general thing. So if I give you an example, let's start with methane. Let's say methane is to meet chlorine, okay? And they go through light, sunlight, okay? We can say light or heat, but we know that we'll be using light, okay? What's going to happen is there's going to be a swap. One of the hydrogens, so we'll now have CH3, 3 hydrogens, and a chlorine, plus the hydrogen now goes and joins with the chlorine that remains because we had 2, now we have it like this. This is an example of what happens. It's a substitution. Do you know what? Because this methane has no other space. The only way to react is by swapping. So it swaps. Okay. Now, there are things that you're going to need to know about this reaction. First thing is how many products. You can be asked about this number. So let's say the number of monohalogenated products. Now, the number of monohalogenated products. Now, when we say monohalogenated, if we look back at this chlorine, at this reaction between chlorine and methane, if there is excess chlorine, this is what happens when there is just 1 mole of chlorine and 1 mole of methane, and it's done. This is what we get. But if there is excess chlorine, if you see them say there is excess chlorine, then this reaction will not end here. It will go through another step. It will react with chlorine again, this thing. And you know what you're going to get? This CH3 will now become CH2. Another hydrogen will be swapped, and you now have 2 chlorines. And then it's going to react again. Okay, this is 2 chlorines, and of course, it's going to give away HCl. Okay, then so it's going to react with CO2. So here we have another reaction with Cl2, chlorine. And what are we going to get? Instead of CH2, it's now CH. So the hydrogens are going. And we now have Cl3, 3 chlorines. And then, of course, we said here, it will release HCl because one of the chlorines that remain here will take the hydrogen that was removed here. And they go. Now, we have another step again, which is it will meet another Cl2. And we will now have, instead of CH, it's just a C. And it is now Cl4, 4 chlorines, plus we will have another HCl being removed. So this is what we now call a polyhalogenated. Polyhalogenated means there are many halogens. 4 of them here, 3 of them here, 2 of them. But when there is only one, like the very first reaction, where you have 1 mole of each, that's the monohalogenated, only 1 halogen, then we can know how many products we can get. Okay, let's say now you have something like this. CH2, okay, let's start with, okay, it's like this. CH3, then CH2, then CH3. This is propane. Let's say it reacts with chlorine to form monohalogenated products, okay, which means only one chlorine will attach on a molecule. So what's going to happen is we want to know how many types of products can we form if only 1 chlorine is going in. Well, we look at the types of hydrogens that we have. We have an H3 hydrogen, and then we have hydrogen as H2. So we have 2 types, the H3 and the H2. So we are going to get 2 products. So the number of products depends on the number of hydrogen types, hydrogen combination types. Let's say hydrogen combination types, right? The combination. Is it H2 or H3 or H? So hydrogen combination type. So in here we have 2, so we're going to get 2 types of products. In the first product, on H2, that's where Cl will go, and it will be like this now, CH3. Instead of CH2, it's now CH, and then Cl, and then CH3. Then the other one is going to be, it now goes on the CH3. So you now have it as CH3, CH2. Then instead of CH3 now, you have it as CH2Cl. Okay? You have it as one of the hydrogens will go and the chlorine will come. And of course, at the end of the day, we will release HCl. Okay? And these are the 2 products. Product number 1 and product number 2. So we can form 2 products because we have 2 types of hydrogen. You must know that. What about if I have something like this? 1, 2, then 3, 4, then 5. Okay? And here I mix this with bromine. Okay? And I need UV light, the sunlight. Okay? So we write HV. What am I going to get? Of course, I know that this bromine is going to be swapping with the hydrogen. So let's just put it like, here is my pentane. Now here we will have a bromine. So, and then what are we going to get as an outcast? We have HBr as a byproduct. One of the BRs that remains will combine with the H that has been removed. Now, how many types of products can we make? Look at the hydrogens. We only have 1 type of hydrogen. For any cyclic alkane, cycloalkane, then it can only make 1 type of product, which is going to be this one. So we are done. This is going to be the only type of product because there's only 1 type of hydrogen for cycloalkane. So that's the first thing we need to know about this reaction, the number of monohalogenated products. Now, the last thing we got to know is what we call the reaction mechanism. Okay? And I'm going to do it in the next video. Bye for now.